In this video, I will explain you what is Wheatstone bridge. So Wheatstone bridge are nothing but resistances connected in this way or in this way. And there is a necessary condition to apply Wheatstone principle. That is, it should be in a balanced condition. What is balanced condition? Here you can see a bridge, right? The current passing through the bridge have to be zero. That is, current passing through galvanometer have to be zero. In that condition, we have a special relation, that is nothing but R1 by R2 is equal to R3 by R4. Now when we can apply this equation? When it is connected in this way and it is in balanced condition, that is current passing through galvanometer have to be zero. Now when current passing through galvanometer will be zero? When the potential at this point is equal to this point. So I am going to mark the point A, B, C, D. So when VC is equal to VD, when both are at the same potential, so there is no level difference. Whenever there is level difference, current will pass. Whenever there is no level difference, current will not go. So when VC is equal to VD, then there is no current passing through this one. And another important relation is, another important thing from the circuit is, let's say current of I comes. Okay, now out of I1 goes through R1 and that I2 goes through R3. So at this junction we can apply Kirchhoff first rule, right? Because this is a junction, three directions are there. Here also we can apply junction rule, here also junction rule, here also we can apply junction rule. What is that? First rule of Kirchhoff law. Now total current entering the junction will be equal to total current leaving the junction. So what is the total current entering the junction? I. What is leaving the junction? I1 plus I2. Okay. And at this junction, we have I1 enters and IG leaves. So remaining will be going through this. But we know IG is equal to 0. So what is total current entering? I1 is entering. That is equal to this one. Let's say this is, for example, Ix. I'm going to just take it as an example. Okay. So Ix plus Ig. But here in this case, Ig is equal to 0. That is the balanced condition, right? If Ig is equal to 0, I1 is equal to Ix, which means these two current will be same, which means I1 will enter and I1 will leave. Similarly, I2 will enter this junction and Ig is 0 entering. So I2 plus 0, the total current entering, that is I2 itself. So the one which is leaving is I2 itself. Clear? So we have applied Kirchhoff first rule here. Now we can apply second rule with the help of two different loops. Okay. So the conditions or the mandatory thing before applying the Kirchhoff second rule is nothing but first rule have to be applied first. Okay. That is current rule or junction rule. Now in loop rule, we will take two loops, loop 1 and loop 2. What is loop 1? This one is loop 1. You can take according to your convenience. I am going to take this one as loop 2. So my loop 1 is ACDA, and my loop 2 is CBDC. Now according to loop rule, what I can do, the total potential difference if you are adding across the loop, that should be equated with 0. So here direction of loop is this one and current is passing along the direction of loop, so potential decreases, that is minus I1 into R1. Now I am going here, there is no current. So if at all if there is current, I have to multiply Ig into Rg, but there is no current, so the value of potential drop here will be 0. Then I will reach here. Then my loop is in this direction, current is in this direction. So potential will increase. What will be the value in increased value? I2 into I3 plus I2 into I3 is equal to 0. I can rearrange. What is that? I1 R1 is equal to I2 R3. From here, I will get a relation, that is I1 divided by I2 is equal to R3 divided by R1. First relation is made. Now with this loop, C, B, D, C. My loop is in this direction, current is in this direction, so potential decreases. What is that? I1 into R2. Now, my loop is in this direction, current is in this direction. So, what will be the value? Plus I2 into R4, opposite, right? This is equal to 0. I can take I1 R2 other side, so I1 R2 is equal to I2 R4. From here, I can take I1 divided by I2 is equal to R4 divided by R2. Now compare these two relations what we have derived, I1 by I2, I1 by I2. I can equate these two. So what is that? Equating LHS is nothing but equating RHS. So R3 divided by R1 is equal to R4 divided by R2. Who has given this and this together? When we have compared, we got this value. Now I'm going to take R1 to this side and R4 to this side. So what will be this one? R1 by R2 is equal to R4. I am taking this side. R3 divided by R4. See the same relation. Wheatstone has given. What is the necessary condition? Ig have to be 0. When Ig is 0, I can say that R1 divided by R2 is equal to R3 divided by R4. This has been proven with the help of Kirchhoff first and second rule. Now, Wheatstone bridge can also be given in this way. Where, see, at A, one end of R1 and other end of one end of R1 and one end of R3 is connected. R1 and R3 is connected at point A. Now, at point B, one end of R2 and one end of R4 is connected. R2 and R4 is connected. At C, RG, this is RG, okay. So at C, RG, R1 and R2 is connected. At C, RG, R1 and R2 is connected. And at D, R3, RG and R4. At D, R3, RG and R4. So if your circuit is given in this way, then check as per this diagram, or simply what you can do, if it is given in this way, immediately make in this way, then you can take the ratio. This divided by this is equal to this divided by this. And that's it. Okay.